Hi, Bobby.
Hi. So let's do some more Thevenin
Sure.
because Thevenin seems to be quite useful.
Very useful. Correct. That's right.
So I have a 9-volt battery.
9-volt battery. Polarity up, no?
Polarity upward is negative.
Upward is negative. Top side is negative. Yeah. Okay. 9 volts, no?
Yeah.
Okay.
From there, I have a 11 ohm on the top side.
11 ohm. Okay. That's kind of an unnatural choice
Yeah.
for. We'll just do 11 ohms anyways.
Yeah. Then there is a 2 ohm downwards.
2 ohms.
Goes
And
by
can I close this?
Yeah.
Okay. 2 ohms.
Then from the 11 ohm, there is a 22 ohm.
22 ohms.
Then there is a 1 ohm coming downwards.
1 ohm coming downwards. Can I close this?
Close it.
Okay.
Bottom we can extend a little bit. That is B. Yeah.
Okay.
Not over.
Okay. I thought this is so easy. I thought you were just going to say A here.
No.
Okay.
So from the junction, that 11.
This one?
Yeah.
Okay.
From there, I have a 12 ohm going in some 45 degrees.
Like a okay.
Yeah.
Okay. 12 ohms, huh?
Yeah.
Okay.
Then a 10 ohm coming towards the end of 22.
Okay.
Yeah.
And don't tell me the top is A.
Yes, of course.
Okay.
You can draw a line and.
Okay. I see. So you want to find out the Thevenin equivalent. This is very hard. How much was this resistance again?
So that is 1 ohm.
1 ohm. Oh, this is hard. I am not seeing any easy ways of making it parallel or series. This is quite hard.
Yeah.
Right? It's not easy to simplify.
If I have a ohm meter, I can measure the resistance.
The resistance, correct. If you have a voltmeter, you can measure the VAB
Yeah.
also.
So what shall we do?
Okay. We need to use some other circuit technique, I think. Some trick or some useful result.
Yeah.
Not a trick, a useful result.
Correct.
To simplify
I
this.
can see one delta symbol there.
Yes, I think that's right. This one.
Yeah.
This is the delta you're talking
Correct.
about. Okay. That is true. Actually, now that is giving me a clue as to what to use. Right? I remember studying about something called star delta, delta star circuits. So now I'm remembering.
So something in the star delta form.
Delta form.
I can represent it in.
You can represent it in
form.
star form.
What is a star? The star or?
I think the circuit looks just like this circuit looks like a delta, no? That must be looking like a star.
Okay.
So maybe what we'll do, we'll look at that first.
Okay.
The result. Come back and try to apply it here. Shall we try that? Okay. So I remember that.
Let's say some RA, RB, RC.
RA, RB, RC. Okay. So that's what we'll do. So we'll write it like this. How shall we do? So we have a delta here, no?
Yeah.
So we have A, B, C, no? So
This A we will.
This AB will not do. We'll use something else. Yeah. Okay. So this is one. We need 3 lines.
Yes.
Right? Maybe the third line, I'll just redraw it like this, no?
Yeah.
It is easier.
Yes.
Just redraw it like this.
Yeah.
So, what we'll do, okay. So, since we don't want to, I'll call this X, Y and Z.
Yeah.
Huh? Why not? And what this is telling is X, Y, Z. I have 3 nodes.
Yeah.
And X, Y, Z, for example. And between each of X, Y, Z, I have a resistor.
Yeah.
Correct? So, if I were to redraw like this, for example, this is just the triangle, I have just drawn it like this. The same thing, I'll just make it a square.
Just taken a pie shape.
Pie shape, correct. That is all. Right? You can easily redraw it like this, no?
Delta?
Like, no, like this, like a delta.
Okay.
I could have drawn it like this.
Okay.
So, each arm being a resistance. Could have done this and this arm and now this arm. Right? X, Y and Z.
Okay.
Now, we'll say this is Rx, shall we say? Something else, no? We need to call it
ABC.
ABC now for the resistance we can use, no? RA, and we'll call this RB and RC. So, between X and Z we have RA.
Yeah.
Between X and Y we have RB.
Yeah.
and between y and z we have RC.
Yes.
Right? Okay. So this is your delta.
Delta.
Right? So this is your delta.
What is the star you are talking?
So before that you mentioned some name for this, no?
Pi.
It looks like the mathematical pi, no? So that makes sense. So this is your pi network, no? Or pi network, right? Okay. And now this star, I am not so sure it looks like a complete star, but it does look like a
Star connection.
Star connection, right? So it looks something like this. So let us say.
Can you draw it inside of this?
That is a good idea.
Maybe in a different color.
In a different color. Okay, let's do that. So what we'll do, we'll draw it like this. We'll draw it like this.
Yeah.
This is the star they're talking about.
Okay.
Okay. So I remember
R1, R2, R3.
R1, R2, R3 we'll see. We'll use R1. We'll call this R2.
Yeah.
And we'll call this R3. And I think I have seen when programming and all, no, when you need to multiply two numbers, you don't use the X. Sometimes you use this, no, something like this.
Correct.
I think this star looks a little bit like the ice, right? Some whole bunch of lines meeting in the center.
Yeah.
Maybe that's why this was called a star. Actually, I have seen in some textbooks, this is also called a Y.
True.
Right?
Yeah,
Isn't that correct?
It actually looks more like
it
a
looks
Y.
more like a Y than a
Only
star.
Its tail is not like
Exactly.
Yeah.
Right? And I have seen some people calling it Y. I have also seen people writing it like this, Y delta, Y delta also, instead of just the letter. I have seen all of them, right? So we have seen a delta, and R1, R2, R3 represents a star or a Y, right?
Okay. So now for the comfort or for the understanding, we have drawn Y there.
We have drawn Y there itself, but in reality, what
it will be a different Y.
It will be a different Y. Correct. Maybe we will draw that here.
Yes.
We'll draw that here separately in black.
Yeah.
We have drawn it in blue here. This dark blue or whatever the color that
Same
is.
color we'll use.
Same color we'll use. Okay. Okay. So we have X, we have Y, and we have Z.
Yes.
Right? We have Z. We don't need to. We can just have this Z.
Yeah.
Like this.
Yes.
And now we have a fourth node.
Correct.
Interestingly.
Correct.
Right? We don't need to name it anything because there is some fourth node. What we are saying is like this.
Okay.
Like this. The nodes are still X, Y, and Z. And we call this R1, R2, R3, no? And R3.
Okay.
And you can, since the X, Y, Z are the same nodes, you can find out if these two networks are the same. If they are the same, then you can find out a relationship between R1, R2, R3 and RA, RB, RC.
So what will be the logic? Basically, if I connect this to some voltage, 3 voltages,
Correct.
it should draw
The same
number,
current.
Same current.
And same power.
Same
Actually, same power makes sense.
Yeah.
Right? The rest of the network will be deciding what current is flowing into the resistor.
Correct.
It should also draw the same resistance. But what you are saying is correct. The power dissipated in the network
will be same.
Will be the same. Right?
Or we can find some resistor that matches
correct.
condition.
That's correct. That's correct.
Should we derive or we can pull out from the memory?
I think we should just pull it out from memory. I think derivation will anyway take a long time.
Yeah.
And I think the students should also try it out
logic
themselves.
is known, I think it's
Exactly. And so this is actually called delta star, or if you go the other way, star delta transformation. Right? So the relationship between these set of resistances and these set of resistances. Okay. So maybe we'll just write one way and do the other way. Okay. Okay. So let us say
we will copy one of these figures, otherwise
maybe we'll copy this figure.
Yes.
This is very useful, no?
Yes.
We'll copy this figure. We'll copy this figure. And I'm looking at it, and I think each one of these resistors, will most likely depend on several of the star resistors,
Correct.
and vice versa.
Correct.
So the relationship will be like that.
Yes.
It is not going to be simple enough saying R1 equal to RA or something like that,
Yeah.
right? Okay.
Also, we are saying almost same current will be drawn.
Correct. Correct.
So that means now between X and Z,
Yes.
I have a fixed voltage.
Correct.
So if I compare RA and let's say R1, RA may have to be larger.
It will have to be larger.
Otherwise, it will draw. I mean,
Correct.
That logic has to work.
That is correct. That is correct. So what will the expression be?
RA.
RA.
So what I remember is RA is equal to.
Yes. I think there are slightly variant ways of writing it.
Yeah.
But we will write maybe one way.
Correct.
And the students will be able to
Correct.
pick it up. So you said it is larger than R1, no?
Yes.
It seems like it should also be larger than R3,
Correct.
right?
Yeah.
So we'll write this
And
in that
it
form.
is not just the sum of R1 and R2 also.
Correct.
So let's write that R1 plus
This is R3.
R3
So we'll write it like this. We'll write it like this. R1
plus
R3 plus
R1 R3 by R2.
R1 R3 by R2. That's right. This is what I remember as well. Right. So it is larger than R1, larger than R3, and the third one you take the product of these two and divided by the resistance of the third arm.
Yes.
Perfect. Actually, now we can write out RB RC.
Yeah. If we can remember this logic, then we can.
Correct. So this is RB, no?
Yeah.
So then you have to use R1 and R2.
Correct.
Right. R1 plus R2 plus R1 R2 by R3. And RC will be you have R2 and R3, no?
Yeah.
R2 plus R3 plus R2 R3 by R1. Correct, no?
Yeah.
So it will be perfectly symmetric.
Yes.
Right? If you write, or rather in terms of the variables.
Correct.
Right? Okay.
So if we have something in star, we can convert into delta.
Correct. If you have something in star, if you know R1, R2, R3, you can convert to delta.
That's what we have done.
Correct. So this is basically star to delta transformation.
Correct.
Right? So this is correct. So the other one, we also need to know the reverse, no?
Yeah.
We should also figure out how to do the reverse also.
Correct.
Because if, okay, I'm looking at these equations, I can't start eliminating the variables. It's going to be very hard.
Yes.
Right?
That will take a lot of time.
We will we'll just write the final expressions and write it like this. So,
so we want expression for R1.
R1, correct. So the expression for R1,
again from the image, what you see is, seems like it's parallel combination of RA and RB and something else.
And something else. Correct. So we'll write it like this.
Yeah.
Parallel combination means
RA-RB by
RA-RB by RA plus RB.
But that's not enough.
That's not enough. So you need to add something else.
Yeah. So it is RA-RB by RA plus RB plus RC.
Correct. I remember this now. Okay. Correct. And now you can write down the others also, no?
Yes.
R2 would be 1 minute. Let me just make myself a little bit of space. So R2 would be, R2 is here. So you have RB, RC.
Correct. By sum of all.
By sum of all of them. And R3 would be RC, RA.
Yeah.
By sum of all of them.
Yes.
And this would now be the delta to star. Okay. Nice. Now, why did you start this discussion?
Also, we started with, we had some
problem to solve.
We had an actual problem.
We actually have a problem there, right?
Yes.
Okay. I remember now.
Yeah.
You noticed the delta shape.
Correct.
And that's what triggered the thought.
Correct.
That, we remembered star delta.
Yeah.
We should be able to use it here.
Yes.
Maybe the natural thing to do, we did delta to star, no?
Yeah.
We'll just convert that delta to star and see what happens.
Yeah.
Shall we just do that?
Yeah.
Okay, let's just do that. So we'll convert this delta. I'll make a copy of this.
Yeah.
Actually, we can just do it here, no?
Yes.
Huh?
That delta alone will do.
That delta alone will do it. So I'll do it in some other color. This color will do. So what I'm going to do, this portion alone, no?
Yeah.
We will convert to star. So X, Y, Z is marked.
Yeah.
So we'll basically need 3 resistors, right?
Yeah.
So X, Y and Z.
Yeah.
And what did we say? So we need to do the delta to star.
Yeah.
Correct? So the resistance R1 from X will be the product of the 2 resistors connected to by sum of all of them. So first step, we'll just write the sum of all of them, no?
Yeah.
Sigma R of the delta is basically 12 plus
44,
10, 22, 44.
Yes.
Right? 44. So everything will have 44 in the denominator. So for X, no, we need to take 12 into 10 by 44.
Correct.
120 by 44.
Yes.
So this R1 is 120 by 44.
Yeah.
Okay. And this R2, let's follow the same convention. R2 is for connected to Y, no? So R2 is equal to 12, 22 into 12. So 44, 220 plus 44, 264, no?
Yeah. Or 22 by 44, we can do some cut there. No?
Correct. 22 by 44 we can cut. So that would just be half. 12 by 2 is 6 ohms.
Yeah.
Okay. Correct. And then this side will be R3. Again 22 into 10, 220 by 44. So that is basically 220 by 22 by 44 is half, so it's 5 ohms. Correct? Okay. This one alone looks.
They are also 12 by 44. That's difficult.
12 by 44 is difficult, no? Yeah. Because if it is 121, we could do it.
Yeah.
But 120 is
60 by
60 by 22, 30 by 11.
Yeah.
Right? That is the best we can do.
It's not helping much.
It is not helping much. We'll just leave it as a fraction for now.
Yeah.
Okay. Now question is, does it help us?
So we will redraw the circuit?
Yes, we'll redraw the circuit. So what we'll do, I will make a copy of this with the redrawing. I'll go past this and okay. We wanted to redraw this portion.
Yeah.
So okay. This is your star.
Yeah.
And we had 5 ohms here,
6 ohms.
6 ohms on the other side, and 30 by 11
Yeah.
ohms. Oh, I can see now that it's a lot simpler.
Yeah.
Right?
It's at least clean.
Yes. Very clean, right?
Yeah.
The Thevenin resistance definitely is very clean.
Yeah.
Now the Thevenin voltage you still have to find, right? Open circuit voltage, but that may also be easy, no?
Yes.
This 30 by 11, there is no current flowing through it, so that may also be easy. Let's just find it out.
Yeah.
Huh?
Yeah.
We'll do the Thevenin resistance first.
Yes.
Huh? That seems to be easy. This is RTH. So we are short circuiting 9 volts.
Yeah.
We'll have 11 and 2 in parallel.
Correct.
So that is 22 by 13
Correct.
plus 6.
Yeah.
So, okay. So 78 plus 22, that is 90. Sorry, 78 plus 22 is 100.
You need calculator, I have.
Yeah, maybe we should use the calculator. 100, we should just retain it as fraction though.
22 by
22 by 13.
13 plus 6.
Plus 6.
That's 7.69.
Yes, can we retain it as fraction? Is there a fraction option? 100 by 13?
That is,
oh, okay. See what I did, no? I just did 13 times 6 is 78.
Plus
78 plus 22 is 100.
Yeah.
So 100 by 30.
Yeah.
The reason, you know why? I saw this 30 by 11, no? I am hoping that that
Sure.
11 will get cancelled.
Sure.
That
Then
is all.
100 by 13.
100 by 13 will keep. That is my only worry. So this portion will give you 100 by 13.
Yeah.
And this is 5 plus 1, 6.
Yes.
So this portion gives you 6.
They are in parallel.
They are in parallel. So we'll first draw the simple one. I hope it gives us something useful. I don't know. I don't think it doesn't look very, we should have just maybe kept decimals, but we'll try this.
Yeah.
So we want R Thevenin here. So
6 into.
So 6 into 100 by 13 by 6 plus 100 by 13 plus 30 by 11, correct?
Yeah.
So this is 600 by 178 plus 30 by 11. Yeah, I don't
I
think.
just calculate.
You just calculated. This now we can calculate.
600 by 178.
Correct.
That's 3.37.
Okay. Plus 30 by 11.
Plus 30 by 11. 6.
6 ohms?
6.09.
6.09. Okay.
6.
So it's a.
I think that's why they have kept this. I mean, this somehow 30 by 11.
30 by 11.
Maybe.
So that it will get very close to 6.
Hopefully, I think.
Okay.
that's
Because I don't think 178 is a
yeah.
is divisible, no? 144 plus 34, no?
Hmm.
144, sorry, 121, 132, 143. Is 178 divisible by 11? I don't think so. Huh? Then it's not going to help you
Yeah.
simplify, no?
Yeah, it's correct only.
This is correct only.
Yeah.
Okay. So 6.09 ohms.
Yeah.
So we found out R Thevenin. The next step is to find out the V Thevenin.
Yeah.
So we'll do that on the next page. So what I will do. Okay.
So through.
So
30
here
by
there is
11, no current.
there is no current here. So this is 0.
Yeah.
So there is, it is just current splitting, no?
Yeah.
So this is 5 plus 1, 6. So this is just half of this voltage.
We'll do
So this-
source conversion twice.
We'll just do that is the easiest, no?
Hmm.
We'll just do that. So why don't we just do that? So this is 9 volts, 11, right? So you want to find out VOC.
Yeah.
So 9 and 11 means there will be a current downwards, which
9
is
by
9 by 11,
Yeah.
and in parallel with 11 ohms. And
Convert once again.
we'll convert once again, and then you have 2, no?
Yeah.
This is 2 ohms, right?
Yeah.
So that is only for Y.
Yeah.
So maybe we'll just do this portion first.
Yeah. So 11 and 2 in parallel is
22 by 13,
yeah.
right?
Yeah.
So then this would become so 22 by 13, and this would now become 9 by 11 into 22 by 13,
Yeah. 1.38.
1.38 volts. Okay, this is okay. So that is only this portion.
Yeah.
So we have done this portion, right?
Hmm.
So that gives you this. And now that is in series with 6 ohms.
Correct.
So 22 by 13 in series with 6. So now I'll show that here, 6 ohms. And then you have another 6 ohms. And then you have this, no?
Yeah.
Okay. So 22 by 13 plus 6 we need to find.
22 by 13
Yes.
plus 6.
Oh, well, why don't we just do 6 by,
correct.
that's just a lot easier,
Yeah.
no? So VAB will just be is minus, because 1.38 is this way, minus,
Divided by whole resistance.
correct, divided by whole resistance. So 1.38 divided by 12 plus 22 by 13
Yeah.
times 6.
So the total resistance is,
So this current is 12 plus 22 by 13, no?
yeah.
So that is how much?
So I should do 12 plus
22 by 13.
22 by 13. That's 13.69.
13.69. Then we need to do, so this is 1.38 into 6 by 13.69.
13 point, if it was 13.8, it would have been nice.
I know, I know.
So 1.38 into
Into
6
6.
divided by 13.6.
This may be 6.09 or something.
0.6.
0.6, sorry, 0.60 or something.
Correct.
Huh?
Hmm.
So minus point with a negative sign, minus 0.6 what?
Yeah.
0.6?
Volt.
Minus 0.6 volts, no? There is no other, the second decimal place is
604.
604 something. So we'll just do it as minus 0.6. Okay, so that means that the final Thevenin equivalent, we'll just write here. So across A and B, no?
Yeah.
So this is minus 0.60 volts.
Yeah.
And this we said 6.09 also.
Yeah.
Okay.
Actually 0.6 and 6.
Yes, practically 0.6
Yeah.
and 6, no?
Yeah.
Oh, ohms. Excellent.
Cool.
Okay, so looks like the star delta transformation,
It
delta
helped.
transformation, it helps.
It helped.
In many cases, because without that, we would have had to solve the KVL, KCL,
Correct.
apply a voltage and then find out R Thevenin,
Yes.
things like that. This really helped us.
Yeah.
Because we just need to do a series parallel transformations. Perfect.
So in some cases, it may be that star, if you convert into delta, it is
It
helpful.
will helpful. Correct. That's right. So we'll just maybe remind them again
Yeah.
of this final result.
Yeah.
So the expressions for star to delta and delta to star,
Yes.
right? And like you said, the way to remember it is if you are looking for RA, which is the delta one, it will be larger than R1, larger than R3 also.
Yeah.
So it is R1 plus R3 plus R1 R3 by R2.
Correct.
You remember that.
Correct.
That's a very nice trick
Yeah.
to remember it.